Hey physics friends, and welcome to Unit 6 Post-Holiday Review Worksheet Answer Key. I'm going to be going through the 3 questions that I gave on that worksheet to just help you through to figure out what's going on and what do we do. So let's get started. Question number 1 says, you launch something at an angle of 50 degrees at a speed of 45 meters per second. On level ground, how far does it go? And how high does it go? So let's make a picture, first of all. So here's my level ground. I'm going to launch this thing at a speed of 45 meters per second, and the trajectory that it follows is kind of this parabola right here. I'm launching at an angle of 50 degrees. And how high does it go? Number 1, it wants to know this distance right here. How high does it go? And then it wants to know how far does it go. We'll call that distance number 2. So one of these is a horizontal distance, distance 2, and one of these is a vertical distance, distance number 1. So step number 1 that we do in these problems is break things into their x and their y components. And along with that comes with my initial launching. I want to make sure that I break this into its x and its y component. So I'm going to use the sine and the cosine to do that. So I'll take 45 times the sine of 50, and you end up with 34.5. And I'm going to take 45 times the cosine of 50, and you end up with 28.9. So my vertical, my initial velocity is 34.5. I'm going to be saying that up is positive throughout this problem, as also to the right is positive. So I'm going to leverage this special spot right here. At this special spot, the final velocity is going to be equal to 0. So when I do this final velocity, I'm going to say that that equals 0. Because vertically up and down, it's the projectile's not going up at this point, and the projectile's not going down at this point. It's going purely horizontal, totally left and right. The acceleration is going to be equal to negative 9.80, assuming we're on Earth. And I want to know how high up in the air it goes. So we could do that. Horizontally, the velocity is equal to 28 point, what did I write there? 28 point, can't read my own writing, 9. And we're also looking for this displacement horizontally. So horizontally, remember, things go at a constant speed. So that's why there's no acceleration over here. That's also why there's no initial or final velocity for that matter, because the initial and final velocity are the same. That's why we have just regular velocity, and the acceleration is equal to 0. Things do not accelerate horizontally as long as you're ignoring air resistance. So I think that we can use these things right here to find my vertical displacement. I think I'm going to use VF squared equals VI squared plus 2AD. So my final velocity being 0, my initial velocity being 34.5, the acceleration negative 9.8, and the displacement is unknown. So I can use all of these things to figure out the displacement, and that turns out to be 60.7. So that's how tall this thing goes. This thing goes 60.7 meters into the air. Now let's figure out how far it goes. Now the only way to figure out how far it goes is you need to know the time, because I'm then going to plug this into the equation. Velocity equals distance over time. So what I'm going to have to do is use this stuff again. I'm going to need to find the time using the vertical components. So I'm going to use all these vertical components again to find the time. So I'm going to use this one, VF equals VI plus AT. And I'm going to use that spot up there, but you got to be careful. When you use that spot, you're going to end up getting half of the time. So my final velocity is 0. My initial velocity is 34.5. The acceleration is negative 9.8 times my time. And when I solve this for time, it ends up being, let's see, what was it, 2 seconds or so? 3.52 seconds. Now remember, that's 3.52 seconds to that special spot up there. So the whole time, if you want to find the whole distance, then you have to use the whole time it takes to get there. And that whole time is you double this number right there. So you multiply that by 2 and you get 7.04. Now you're poised to solve this problem. 28.9. The displacement is unknown and the time is 7.04. So your displacement, 28.9 times 7.04, turns out to be 203 meters. So this thing runs 203 meters horizontally. That's question number 1. Number 2. You're launching that same speed, 45 meters per second, except now you're launching it from an elevated position. So this is the ground. This is supposed to be horizontal here. You're launching it with that same speed of 45 meters per second, and it's 50 meters off the ground. So this thing follows a trajectory similar to this, and this question wants to know how far from the base does it land. So just like in the last problem, when we have a projectile problem, we're always going to break it into its y and its x components. Vertically, there's an initial velocity. So when you fire something and you only fire it horizontal, you're not firing it up and you're not firing it down. The initial velocity is 0. And that freaks people out. What do you mean, Mr. Hare, that you're launching this with a speed of 0? Vertically, I'm launching it with 0. I'm not firing it up and I'm not firing it down. Vertically, it's 0. Horizontally, the velocity is completely 45. Like that. People make a big mistake a lot of times in these problems and they say, oh, the final velocity is 0. No, that's not. When that thing hits the ground, it's actually moving pretty fast. When this thing hits the ground, it's moving down and it's moving forward. It's moving forward at 45 and it's moving down at some, when you solve this for a final velocity, that's what this is right here. That's the speed with which it hits the ground vertically. So you don't know the final velocity. I'm going to say, just for simplicity's sake, that up is positive. That if I was doing this personally, I would make down positive. That would make everything my acceleration is positive and my displacement is positive. But just to keep on the same page and to keep continuity through all these problems that I've been doing, I'm going to say up is positive. And if you always make up positive, the acceleration is always going to be negative 9.8. And my displacement in this case is negative 50. So I'm looking for this distance, and you can kind of maybe see a correlation between the last problem and this problem. The only way to find the distance is that you need time. And once you have that, then you're going to use velocity equals distance over time, and you can solve the problem. So what I'm going to do is I'm going to use these things right here to find my time. And once I have my time, I'll put it in there. I'll put that time over here, and I'll be done with the problem. So let's get started. So I think that the equation that doesn't involve VF is this one. D equals VIT plus 1/2 AT squared. So my displacement is negative 50. The initial velocity is 0, so 0 times anything. That's very nice. I don't have to use the quadratic formula. So I solve this for the letter T, and that time turns out to be 3.19 seconds. Now, contrary to popular, this is the time here. You don't have to double this. Since I used this displacement of 50, that's the time it takes to get to that displacement. So that's the entire time. So there's no need to double in a problem like this. So now I can finish this problem off. The velocity is 45. The displacement is unknown, and the time is 3.19. So you take 45 times 3.19, and you get 144 meters from the base of the cliff. Right there. Question 2. The final question. You're taking a corner. It's really icy outside, so here's kind of like my sidewalk. And here's me running. It says, here's kind of the forces that are acting on me. I've got a gravitational force and a normal force, and there needs to be a force turning me. And that force that is turning me is friction. Like the friction between the ground and the person is what turns them. The more friction you have, the tighter, the faster the corner you can take. So I think that we know some of these forces. It tells me in the problem that I'm 68 kilograms. So if I take 68 times 9.8, I get 666 newtons. And that's what my normal force is also. And then to find friction, the force of friction, it's equal to the coefficient times the normal force. And in the problem, they tell you that the coefficient of friction is 0.3. And the normal force, so now you can figure out the force of friction, and it's 200 newtons. And I'm just going to, in my brain, I don't want to write it in scientific notation. I'm just going to keep it in my brain that I know that this carries with it 3 significant figures. So, how do we do this? In a problem like this, whenever you turn a corner, something turns you. And I've already kind of given you a hint as what's turning this object, and it's friction. And the turning force we know as the centripetal force. The centripetal force is mass times your velocity squared over your radius. And we already found friction. It's 200 newtons. We know the mass from the problem they give you is 68. And we know the radius of this corner, and they tell you already that it's 10 meters. So you take 200, divide by 68, multiply by 10, and take the square root, and you'll find that the fastest speed you can take this is 5.42 meters per second. It's not very fast when you think about it. 1001, 1002, you're going probably 15 feet every second, which is kind of fast, but I'm sure that you could probably sprint quite faster than that. So there you go. That's the 3 questions that we had for our review. I hope that you are doing well, and we'll talk to you later.